Welcome to another Olympiad training session with Professor Pillay, presented by the South African Mathematics Foundation. Remember to get your copy of Professor Pillay's Olympiad training manual.
Good afternoon, everyone. I must apologize for the delay. We had some technical problems. Immediately, I want to welcome our guest, who is going to be with us for 10 minutes, Perpetua Ganga. And she is from the Minerva University, based in California. And she's going to speak to you for 10 minutes regarding a program, I presume, that she has from the University of Minerva, which she wants to discuss with you. All right, over to Perpetua. Welcome, Perpetua.
Thank you, Professor. Let me share my screen real quick and try to do this as fast as possible. My name is Perpetua Nganga, and I'm the Africa Outreach Representative for Minerva University. I'm excited to have this conversation with you. We get quite a number of South African students, and we've had some graduates, and so I just want to make sure that you have information on the programs that we offer. I was actually in South Africa last week, and I got to meet with Ellie from the Math Foundation, so I'm happy to get to speak to the students directly this time. So I don't know how many of you have heard of Minerva, but we have an educational experience that has been designed to prepare students to be effective leaders and innovators. We're in a world where we need, more systematic thinkers and leaders who are able to understand and address complex problems. And so our curriculum is practical. You get a lot of practical work in getting cognitive skills that you can use for leadership collaboration, in addition to the degree that you graduate with. And I'll leave my email so that anyone who's interested can reach out to me and ask me any follow-up questions beyond this presentation. So in terms of some of the skills that we really focus on in students' first year, we have personal abilities such as critical thinking and creative thinking that are increasingly important for the 21st century and how interconnected and complex our world is becoming. On the other hand, we have interpersonal abilities such as effective communication and interaction. Whether you're a computer scientist or a business person, all these are skills that you're going to use to be able to navigate the world of work. And so you'll see that in your first year, these are the 4 core courses that all students will need to take. And we focus on what we call big questions. So for the next 2 weeks, if all 100 of you are our class of 2026, you're joining in September, you'll see for the next 2 weeks, maybe you're trying to understand how do you feed the world. So you'll approach that question from your computational thinking and math perspective in your critical thinking class. You'll approach it from a communication standpoint, from a scientific method standpoint, from a systems perspective, because our mission is to nurture critical wisdom for the sake of the world. And we get quite a number of Olympiad students, math, chemistry, physics, from across the world every year. And so in terms of the majors that you're able to take, we have 5 main colleges: arts and humanities for history, philosophy, ethics, and the law; computational sciences for math, artificial intelligence, data science, applied problem solving, and the like; the natural sciences for genetics, biochem physics; social sciences for economics, political science, neuroscience, governance, and the like; then business, these are your finance students, brand creation and management. The beauty of this is that you can double major, so you can graduate with a degree in computational sciences and business. And this is often where a lot of innovation comes from, in big ways and small ways. We have one of our South African students, she graduated with a degree in data science and economics, and is now the head of growth at a global decentralized finance organization, one of the world's biggest. And they got around, I think, $8 million of funding last year, and she's the head of growth. So you'll see how you'll get tangible skills. And sometimes I give examples so that what you've seen on the paper makes more sense. So you can refer to our YouTube channel just to see some of the things our students are doing, and especially African students, because I think it's always nicer and easier to see people who have been through the same education system and the like. Now, in terms of how we believe students, the best way to facilitate this for our students, the way our courses are structured, we ensure that you're getting breadth across different disciplines, even as you're gaining depth of mastery in your field. So that's why you see the first year, there's that broad sense of skill set. So even if you're an arts and humanities majors, you learn how to code, you learn public speaking, just all these different things so that you're more well-rounded. Second thing is active learning. It's probably my favorite because in a Minerva class, you read for yourself before class and you come in to have a discussion. So this is based on scientific evidence on how students learn best. So you're able to retain concepts better and understand them better and transfer them to different contexts. The third one is our class technology. Now I know post-pandemic people hear virtual learning and they get a bit apprehensive, but this is a platform that has been designed for learning and discussion-based classes with a lot of interaction, and you're also able to track performance across different classes over time, get a lot of frequent informative feedback from your professors. I know we might not be able, I don't think we have time to watch the video, but I can show, this is how it looks like. Your classes are small. I think the maximum is like 19 students per class. You can go into breakouts, inbuilt coding platform, or you can code. Your professor has a button they can press and see who hasn't spoken during class. It has been designed for learning. Because we want students to be able to participate. I know every class has that one couple of students who would consistently like engage during the session, but we want to make sure that all students have that opportunity. Now, the back end looks like this. Your professors watch your classes and they grade you based on what you're saying in class. So because we don't have traditional form of exams, you have to actually do your readings and get a lot of consistent, it's mainly for continuous learning. So you have to do your readings, come to class prepared, you're graded based on what you're saying in your classes. You can see on the right, that's our grading scale, and you get feedback on what you said, what you wrote. So there's that, and there's also being graded based on your projects and assignments. Each class has a couple of assignments just to make sure that you're learning effectively. Now, I don't know if anyone has heard of Minerva, but often this is what students usually have heard. We have a global residential rotation, and what this means is that students spend each semester in a different country. So you start off in San Francisco, California, where we're based, then they're in Taipei in Taiwan, Seoul in South Korea, Hyderabad in India, Berlin in Germany, Buenos Aires in Argentina, London, then you finish off in San Francisco for graduation. It's been designed this way so that one, it builds on academic learning. One, you're working with, we have what we call Civic Partners. These are 8-week-long projects that students are able to do with some of our partner organizations. As I mentioned, it's very practical. Whatever it is your line of interest is, we have a range of partners that students get to work with. Right now, we have a class in South Korea. One of their partners is Samsung, and each city has like 20 to 30 partners. So by the time you're graduating, you have 4 years worth of experience with actual companies. This is the Ministry of Education in Argentina. I'm a development economist by training, and I also graduated from Minerva. So I'm based in Nairobi. I'm the vice president and head of partnerships for one of the nonprofits here. And this is the Ministry of Education in Argentina. And our project as an economics student was to understand how to reintegrate teenage moms into the education system. It's a problem in Kenya, Argentina. I'm sure it's a problem in South Africa. So you get to apply what you're learning in class to a real life project, and then you get to learn how they're solving problems. So yeah, I think in just this last 2 or so minutes, just some of the professional experience the students have had. We have a coaching and talent development team that works with students to help you for interview prep, jobs, all these different sorts of things. You're assigned a coach in your first year. So all these opportunities have been intentionally, students have been prepared for them. We have mental health coaches who work with students in the different cities. We have a diverse class, so you're living with students from more than, I know right now we have students from around 85 countries. So in a class of 190, if you have students from 50 plus countries, you see you're not a minority. There's such an irreplaceable depth of intercultural competence and learning from one another that comes out of this. Yeah, so in terms of admissions, we're looking for top students from across the world. That's why we work with organizations like SASDB for the debate students, the Olympiads, because we take less than 2% of the students that apply, and we get really strong applications from across the world. So I'll not get into those details, but reach out to me and leave my email in case you want to understand our application process, because it's quite different. We also have scholarships for students, even if you're international students. So it's need-based, meaning you get a financial aid package based on your family's level of need. I know that's usually a concern for international students. So that's not a point to worry about because there's financial aid for students. Then there's an additional $10,000 scholarship for Olympiad students who exhibit need, for an Olympiad student, the top one. So yeah, I think I will wrap it up there. Try to make this as fast as possible. I'll just leave my email in the chat and you can feel free to reach out to me if you have any questions. All right.
Okay, thank you very much, Perpetua, for that very quick and brief introduction to what you are doing. Her email address has been given to you. We will put that also on our Google Classroom so that any one of you can write to her and ask for more information so that, and at the same time, this session has been recorded, so you can look through and go, and if there are points that you missed, you'd be able to catch up. All right, with those few words, we want to go straight to our class. Please, I beg you again, once more, please mute your microphones. We would not want to be disturbed as we go along. Keep looking at that little icon at the bottom left of your screen and make sure that it's crossed. Okay, so let's go straight to our to what we're going to do today. Okay, last week we stopped at the problem number 24. We didn't do this. We went up to that and we didn't do this. And just one moment, please. Okay, this was a geometry problem, and the question here, as you can see, you have a right angle triangle. I'm sorry, I'm a little put off because there's a problem here. You have a right angle triangle, and it is given that E is the midpoint of this of AC. At the same time, it's given that BA is equal to BC. So this is an isosceles right angle triangle, right? There's 90 degrees here, and this is the midpoint. And then one of the vertices is joined to that midpoint. So in fact, what you have here is these two are equal. And from here, there is a perpendicular which is drawn. And the question is, if you know AB equals AC and is given as this, what is the area of triangle CEF? So we need to calculate the area of CEF. All right, there are many ways of doing this, but the simplest way I have, I'm going to do it like that. Hopefully you have tried it because we stopped here last week. What I'm going to do is, instead of using this rather cumbersome thing, I'm going to let x be equal to 20 root 3. The reason for that is I want this to be x, these two equal parts, and we can see 2x is equal to the whole thing. So x is 20 root 3. So therefore, because this is isosceles, that is 2x. And we need to calculate the area of this triangle. We know x, so we know the area of the large triangle. So how do we do this? Well, you have to use the formula. I'm sorry, I didn't leave space for this. I can't understand what happened. Anyway, you have to use the formula for the area of a triangle, and the area of CEF the area. I'm going to use the formula. If I call this EF, if I call it Y, and I call the angle between X and Y theta, then the area formula says this is half XY sine theta. Okay, there are some grade 10s in the class. They might have seen this before, but just remember the area of any triangle is half the product of two sides, XY, times the sine of the angle between them. All right, now we know what X is, but we don't know what Y is, and we don't know what theta is. So let's see how we're going to proceed with this. Now remember, this is theta. This angle here, which I'm pointing to, is 90 minus theta. So it means that this angle here is theta, because this angle added to that gives you 90, and this angle added to theta gives you 90. So that angle there should be theta. So from there, we can see, okay, here you have a right angle triangle with the two sides known. So therefore, you can calculate the hypotenuse. The hypotenuse is the square root of x squared plus 4x squared, which is the square root of 5x squared. So BE is the square root of x squared plus 4x squared, which is square root of 5x squared, which can be written as x times square root of 5. So this part here is x times square root of 5. And that allows you to calculate the sine of theta straight away. Because you've got the three sides of this right angle triangle. The sine of theta is opposite. Opposite theta is x over the hypotenuse. And you see that this is 1 over root 5. So we have sine of theta is 1 over root 5. So this part is known, x is known. So the only thing is we need to calculate the y. Now, how do we calculate the y? Well, we can work out the area of triangle BEC. You see this triangle, these two are equal at the bottom, and the area of BEC is the same as area of this triangle, because they got both these triangles have got the same base and the same height, which is 2x. So the area of triangle BCE is the same as the area of BEA. And we know the area of BEA, you can see, is half base times height, and that is x squared. So the area of this triangle here is x squared. Sorry, I have to squeeze everything here because I didn't leave space. So the area of this triangle is x squared. I'm talking about this area here, that. So what is this equal to? This is the area of this is the sum of two areas. It's the area of this, which we wrote down as half xy sine theta, the area of this small triangle, plus the area of this triangle, but that's the area of a right angle triangle, and the area of that right angle triangle, this is plus the area of this right angle triangle is again half base times height. So it's half y, that's your base, times the height, which we saw to be x root 5. Sorry, root 5 times x. So if you make all these substitutions, you will see that you've got, remember, sine theta is 1 over root 5. So I'm going to put this as xy over 2 root 5. Sine theta is 1 over root 5, and the 2 goes to the bottom. And this here is xy times square root of 5 divided by 2. See? Right, so you have that area can be found in two different ways. One of them is by just observing that this area is equal to that area. The other is that the area is the sum of these two areas. But if you look at this carefully, you see x cancels. So I can multiply right throughout by 2 root 5 and cancel the x's. So if I put 2 root 5, multiply right throughout by 2 root 5, 2 root 5 x squared multiply the left hand side and multiply this by 2 root 5, and you get xy, because this denominator cancel. But this has to be multiplied by 2 root 5. The 2 cancels, and what you're left with is 5xy. Root 5 times root 5 is 5. So when you multiply by 2 root 5, you get 5xy. So here you got 6xy. And therefore you can calculate y in terms of x because the x cancels. And you have that y is equal to 2 root 5 x cancels times x over 3, because you have to divide by 6. So y is equal to this divided by 6x, and you have an x. All right, so we got y, and then now all we have to do is to go back to this equation here, because this is the area that we need to calculate. And what is this area now? It's now equal to 1 over 2 times x, and we just calculated y is 2 root 5 over 3 times x. That's y. And sine theta, we saw earlier on, was 1 over root 5. And now the root 5s cancel. The 2's cancel. And Actually you have root 5 over 3. Sorry, it's supposed to be root 5 over 3. So this 2 doesn't cancel. And if you simplify this, you get x squared over 6. Okay, the 2's cancel, so I shouldn't have had the 2 at the top there. Okay, and now finally you can substitute for the x, and x squared is 20 root 3 times 20 root 3 divided by 6. And see, root 3 times root 3 is just 3. And 3 over 6 is 2. And eventually, you see the answer is a lovely number, 200. So this triangle has got area 200. As you can see, it's quite a sort of deep problem because it's problem number 24. So there are other solutions which involve constructions, but I'm not going to take time to do that. I found that this is the easiest solution, although it looks rather complicated. Okay, this will be recorded. So if you didn't follow this, you can always go to the recording and you'll have all the time in the world to understand it better. So let's now go on to the next problem. This is the last problem of 2018. The last problem of 2018 okay, I'm going to read the question. What is the smallest integer larger than root 3 plus root 2 all to the power of 6? So let me go to the whiteboard so I'll have enough space. I'm going to repeat the question. Okay, so the problem is root 3 plus root 2 raised to the power of 6. Now, if you use a calculator, you will be able to do this thing very quickly. But you have to do this without a calculator. And how do you calculate the 6th power of this? It'll take quite a long time. And then even then you got square roots and so on, and you don't know how to do that. All right, so there is a way of doing this. The only thing we need to know is that root 3 is approximately 1,7. When you work out 1,7 and square it, you'll get 2,89. So it's about that. And the square root of 2 is approximately 1,4. When you square this 1,4, some of you will know, it's going to be 1,96, which is approximately this. Those are the only two things that you need to know, right? And so how do you calculate this? It's not an easy problem. It's a last problem. So just it uses some strategies, some tricks, which are quite useful in other problems. So you see, the first thing I do is I'm going to give a name to this. I'm going to give a name to the unknown, root 3 plus root 2. So the question is, what is a to the power of 6? And we want to know what is the largest integer larger than this. I'm sorry, what is the smallest integer larger than this? So if a to the power of 6 is 247.5, just for argument's sake, then the answer will be 248. It will be the largest integer larger than this number. But we don't know what a to the 6 is, so we're going to try to approximate it now. And the way to do this is you observe that root 3 plus root 2, if you multiply this by the conjugate means where you replace the plus sign by the minus sign, Then you got a plus b into a minus b, and that is equal to a squared minus b squared, which is 3 minus 2, which is 1. So when you multiply this number by its conjugate, you're going to get 1, which tells you that root 3 minus root 2, this part here, times this equals 1. Now this is your a. We call that a. So root 3 minus root 2 is 1 divided by a. Because a times this is equal to 1. So root 3 minus root 2 is 1 over a, right? Now I want to get to, the reason why I'm doing this, I want to get to a squared and work my way to a to the power of 6, all right? So I've got a is this, but instead of calculating a squared, what I'm going to do is I'm going to calculate a plus 1 over a all squared. You'll see just now why. The nice thing about this is that you have a squared, and the middle term is 2 times the product. When you multiply these two, you get 1. So the middle term is 2 times 1, which is 2. And then the last term is 1 over a squared. So that gives you a squared plus 1 over a squared. It's equal to this squared minus 2, right? But I just want you to notice that this is a, and we said 1 over a is root 3 minus root 2. So a plus 1 over a simplifies quite nicely because the root 2's cancel, and a plus 1 over a is just 2 root 3 plus root 3. So this part here is 2 root 3, a plus 1 over a, and you're squaring it. And you bring it to the other side, and you have 12 minus 2 is 10. So we can calculate a squared plus 1 over a squared exactly. See, it's equal to 10. And the trick is to work out a plus 1 over a all squared, and then remove the middle term, which is a whole number, and then you get a squared plus 1 over a squared. Now, I want to do the same thing to a to the 4th plus 1 over a to the power of 4. And here, it's a similar thing. I can square a squared plus 1 over a squared, square this, and you have a squared plus 1 over a to the power of 4. But there's a middle term, just as in the previous case. When you multiply these two, once again, you get 1, and you double that, you get 2. So you got a 2 here. That has to be subtracted to make these two equal. The middle term, if you take it out, you're left with that. Now we've already calculated this thing. It's 10. So this is 10 squared, which is 100, minus 2, that's 98. So a to the 4th plus 1 over a to the 4th is 98. So now we ask ourselves, what is a to the 6th plus 1? Because I need to get to a to the 6th. That is the problem. What is this thing here, which we called a? What is this equal to? Well, now I have to work out a to the 6th plus 1 over a to the 6th. Now here, I notice that this is a sum of 2 cubes. This a squared all cubed plus 1 over a squared all cubed. And you know how to factorize the sum of 2 cubes, right? So how do you factorize the sum of 2 cubes? Well, it's equal to a squared plus 1 over a squared this plus this, and factorization for a cubed plus b cubed is a squared minus ab. Oh, I'm sorry. It's a plus b into a squared minus ab plus b squared. Right, so this is a squared. This is your a plus b, a cubed plus b cubed is a squared plus. And now you square the first term, a to the fourth, and then minus the product of these two, and you get 1 a squared times 1 over a squared, and then you get b squared, which is 1 over a to the power of 4. And these numbers we've already calculated. A squared plus 1 over a squared, if you recall, was 10. So this part here is already 10. And here you have a to the fourth plus 1 over a to the fourth, and we had 980. This is 98 at least. This is 98, these two. We calculated this, and you subtract 1, so it's 97. So you get 10 times 97, which is 970. Okay? And finally, now you see, you've got a to the sixth plus some other number equals 970. But now what is this number here? Right? If you look at this number, you see this is a very small number. It's actually a number which is between 0 and 1, because a is certainly positive, right? So 1 over a to the sixth is less than 0. Right? But this is actually 1 over a is root 3 minus root 2, all raised to the power of 6. See? And I told you that we can assume that we know what root 3 is and root 2 is. So when you subtract these two quantities, you're going to get a value which is about 0.3 approximately. When you raise that to the power of 6, you're going to get a very, very small number, right? Because it's 3 over 10 raised to this. I think you get something like 0.0000729. It's a very small number, okay? So what is the meaning of this? The meaning of this is that this quantity here is a very tiny number. And when you add it to this, well, it's certainly, this is less than 1. And this is less than 1, certainly. So you have that this quantity here is a number which is positive, but less than 1. In fact, it's very much less than 1. So when you add a to the sixth plus a number which is smaller than 1, the answer is 970. So this is a number which is, you have to add a small number to get to this. So therefore, the answer to our problem, this number here lies between 969, a to the sixth, and 970. Because this number here lies between 0 and 1. And you're subtracting, you see. You're taking 970 and you're putting it to the other side. You're adding this quantity to get to that. So therefore, a to the sixth will be this. So the largest integer, which is greater than a to the sixth, is 970. Now, that is quite a mouthful, guys. You know, you can see it's problem number 25, and it's not an easy problem at all. I have to confess that it took me a long time to solve this thing, to get all these tricks in place to get to this. All right, so I did it because there will be students who will want to know what the answer to this last question is. And so here you have it. And if those who are interested can go through this thing and learn some good tricks, especially about when you're squaring a plus 1 over a all squared, you get something which is quite nice. That's quite useful. Okay, so let me, that takes care of 2018. Now we want to go to 2019. That's the paper that we were supposed to do today. All right, I completed the 2018. It took me, I did not complete it last time, and now I've completed it. Now we can go to these problems in 2019. We are running very badly short of time, so I'm not going to race through it, but I'm going to try to do it as briskly as possible. The first few questions, so I'm going to assume that you've already seen this. Okay, this is very easy, and the answer is 12. I'm not going to do that. You can see it on the screen. So when you, when I send you the recording, you will have the answer and you can check it out. The next one, the answer is 120. It's a simple problem on percentages. So you can work it out and check to see whether you got the right answer. And the third one, just a brief comment on this. If 6 cats can catch 6 rats in 6 minutes, how many cats are needed to catch 12 rats in 12 minutes? So my answer is 6 cats, right? And I give it a very brief commentary. I said, give them 6 more minutes. So in 6 minutes, these 6 cats will catch 6 rats. It's given them. If you give them the same cats, if you give them 6 more minutes, that's 12 minutes, right? They will catch another 6, which is 12 rats. So you don't need 12 cats, you need 6 cats, right? To catch 12 rats in 12 minutes. Just think about what I said there and you'll see it's common sense. Okay, this one here is a problem of indices, which I'm not going to do. You can see what the answer is. And this problem here is a simple problem in geometry, right? It when you unpack it, you will get this diagram here, and the problem is to find x, and you can see PQT. Yeah, so you can see PQT is exterior angle is equal to the sum of the interior opposite angles, and it's very easy to calculate that one. All right, so let's get on to problem 6, right? The first few problems, as I said, were very easy, so we don't spend any time on them. Problem 6 says, when a number is added to 1/4 of itself, the result is 30. So let the number be x, right? We don't know what the number is, so you give a name to it. 1/4 of itself is x over 4, and you are adding your number, which is x, to 1/4 of itself, which is x over 4, and the result is 30. Now, this is a very simple equation, and you can work it out, and you see that x is actually equal to 24. I'm not going to spend any time on that. You can do it yourself. Right, so the main thing there is to get the equation. A number is added to 1/4 of itself. Once you got the equation, then the rest is easy. Okay, let's get on to problem number 7. Problem number 7 says calculate the area of a triangle formed by joining the points A, the coordinates are given, B and C. All right, in the Cartesian plane. So we have to draw the triangle using these coordinates, and you need to find the area of the triangle. And I've done it. Drawn the triangle. You can see I've got A is a point which 3 is 6. So the coordinates of A are 3 and 6. 3 and 6. So the X coordinate is 3, from here to here is 3, and the Y coordinate is 6, going right up to there. Right? So we plot that point. Then when you plot B, you've got X coordinate is just 1, the Y coordinate is 2, and C, you see, is the X coordinate is 5, the Y coordinate is still 2. So in other words, these 2 points are at the same height above the X-axis, because they have the same Y coordinate. So when you draw this line is parallel to this line. Okay, and now you can find the area. How do you find the area? Well, you have to work out the base. The formula is the area is half base times height. Okay, now what is the base? The base is that one. Okay. Now, when you look at the X-coordinate is 1. So what does that mean? It means that the distance from here to here is 1. That's the X-coordinate for B. And as far as C is concerned, the distance from the X-coordinate for that is 5. So when you go up from there to there, it's actually, let me just draw this a little bit neater. So if you go from there to there, that distance there is 5. So what does this mean? It means that this part here, the base, is 5 minus 1, which is 4. So this part is 1 and the whole thing is 5. So from here to here would be 4. So it's just the difference between the two X coordinates, 5 minus 1. That's the general rule. If you have the thing is parallel to the X-axis. Now, the same with the Y coordinates. This Y coordinate here is 6. And here, at this point here, the Y coordinate is 2, because all these points have got the same coordinate, Y coordinates, the parallel line. So the Y coordinate for the whole thing is 6. This from here to here is 2. So that distance is 4. And that gives you the height. The height of the triangle is you have to go right down to come to the Y coordinate 6. Excuse me, and you subtract 2 and you come to that. So that's the height. And that gives you that the area is 8. 16 divided by 2. So here in this problem, you need to plot the coordinates and then just observe that one of those sides of the triangle is parallel to the X-axis, and that makes the problem very much easier. So you can find the area very quickly. Okay, and the next one says the average of 4 consecutive odd numbers is 32. What is the largest of these integers? Right now, so you got 2 ideas here. You got the idea of average, and you got consecutive, and you also got odd, right? Okay, there are 4 consecutive odd numbers. So let me give a name to the smallest one. Let x be the smallest. The smallest of these consecutive odd numbers. So what does that mean? So x is an odd number, it's the smallest. The next one is consecutive, so you have to add 2 to get to the next odd number, right? The odd numbers, 13, 15, 17, 19, and so on, they all are separated by 2 units. So to get to the next one, the consecutive one, you have to add 2, and likewise, you keep adding 2, and you will get the 4 consecutive odd numbers. So these are your 4 numbers, but the average of that is 32. So what is the meaning of average? Average means if I add all of them and divide by 4, which I can do straight away, if you add them, x plus x plus x plus x, that gives you 4x, and 2 plus 4 plus 6 is 12. Right? When you add them and divide by 4, you're going to get 32. Right? The average means the sum of the numbers divided by the number of numbers. Okay, and there you can see the 4. This is 4 into x plus 3. And when you solve this, you get x equals to 29. And I'm not going to do that. It's a simple equation. But the question is, we must read the question to answer it. So what is the largest of these 4 numbers? And the largest is that one. That's the largest. X is 29. So this is 35. 29 plus 6 is 35. Okay, you could have done it like this. I don't know what the odd numbers are, but let me put spaces for the odd numbers. And imagine now, I got this plus 2, plus 2, plus 2, and these 4 numbers, where is the average? The average will be halfway between these 2 numbers. So this number here will be 32, which is halfway between these 2 numbers, right? These are consecutive odd numbers. So this is 31, and this is 33. 31 to 32, 33. So therefore, the largest will be 35. This is a quick way of doing it, because you try to understand what you mean by averages. You picture the 4 numbers on the number line, and the average would be right, in between, halfway in between those 4 numbers. And the halfway number between the 4 numbers is this number here. That's an even number. So you have to go 1 this way, 1 that way to get to these 2 numbers. And you get, this is 33, so therefore the answer is 35. And that's the largest. So that would have been an easier way of doing it. That's problem solving. See? Without using x's. The next problem is you got the triangle HA equals HR. So you are given an isosceles triangle. HA equals HR, which means that the angles, the base angles are equal in any isosceles triangle. And it's given that AYR is 130. The question is to calculate HYA. What is HYA? HYA. And we need to calculate that angle. I'm just going to change the color of this. Okay, so how do you calculate? So you need to calculate this one here. That's your unknown. Let's give it a name X. Right. Or maybe not. Let's just hold on with that. Uh, Now let's have a look at this problem here. We need to calculate that angle there, as we said. Now we know that this is isosceles. So this entire angle is equal to this entire angle, which means that these two angles are equal. So I want to reserve the x for this, because this whole angle is equal to the whole angle, and this, both of these are 40. So the remaining parts will have to be equal, right? So now that allows you to calculate the small angle here, because you've got a right angle, you've got a triangle with one of the angles 130, and when you add the three angles of a triangle, 130 plus 2x, you're going to get 180 degrees. The sum of the angles of a triangle, 180 degrees. That allows you to calculate x, because 2x then is equal to 50 degrees. So x is 25. So this angle here is 25. But the conclusion from that is that the small triangle, okay, we don't need to calculate x. I just realized you don't need to calculate x. All you need is that these two are equal. Right? Because these angles are equal, these sides will be equal. That's the property of isosceles triangles. Now that means that these two triangles here, you can see they've got the same sides. You've got a stroke, a double stroke, and the middle line. Stroke, double stroke, and the middle line. This is common. So these two triangles are congruent, which means that this angle and this angle are equal. See? So if you call this angle y, it's going to be equal to this, because these two triangles are congruent. Side, side, side. But now you can calculate this angle y, which we need to calculate, because these three angles add up to 360. So 130 degrees plus 2y, that's y plus y, is 360 degrees. And you can calculate y. I'm not going to calculate it, it's a simple calculation. Y turns out to be 115 degrees. So the idea is to get to an equation involving that angle, but you have to do that, you have to observe that these two angles are equal. But at the moment, you can't say that they are equal. Because these two triangles are not congruent, you see. You got two sides, but the angle is not included. 40 degrees is not between these. So you can't conclude these two triangles are congruent, because the congruency condition is not satisfied. You need to have two sides and included angle. That angle is not included. So that is why we need to get to these two sides are equal. And the condition for congruency is now three sides, all right? And therefore, those angles are equal. All right, so that takes care of that problem. Problem number 9. We get on to the next one. As I said, I'm going rather briskly. At the end of the session, we will give you a chance to ask questions, but I'm going to exploit the fact that the recordings will be posted, so you will have a chance to look at them again, and you can take your time and try to understand it when you get the recordings. Let's get on to problem number 10. In how many ways can the letters of the word SAMO be arranged if the vowels must always be in alphabetical order? So you got the word SAMO, and you take the letters and rearrange them. So there are many ways of rearranging these letters. SAMO, You can put AMOS or SOMA, or you can put OMAS. But they want the vowels to be in alphabetical order. The vowels here are A and O, so this is allowed, but these two are not allowed. So the vowels are not in alphabetical order, right? You must have the A before the O. So the words that you create must always have an A before the O. Okay, so let's see how we're going to do that. I'm going to get to the next screen. Now, I've actually listed all the possible ways here in which the A comes before the O. Right? A is always before the O. So I start with A, and then I put an S in front, right? And then I'll get MO, and I put S in front again, and put OM, turn them around. Those two come together in pairs. With AM, the first two letters. Now the AO, yeah, here you got the first two letters are MA and SA and where did I put this? Oh yes, and then MS. Here you see I got the AO at the end, so you can only interchange those. All right, so altogether the answer is 12 if you count all these things, because there are 6 pairs, and each pair you got AO. You see, if you got AO here, the S and M can be interchanged. So you have SM and MS. So I could have done it like that. So anyway, if you do it, no matter how you do it, if you write down all the answers, make sure that you have counted every one of them, then you will see that there are 12 of them. But there is a logical way of doing this, and I want you to just listen to this because it's very, I'm going to give you some important artillery to solve problems like this. Now, you are looking for a 4-letter word with A in front of the O, like in this case here, right? So the first thing to do is, in how many ways can you choose A and O, right? If you think about it, I can do it like this: AO blank blank. I can put A blank, A blank, O blank. I could have had A blank blank O. A comes before O, right? And A is in the first letter. Okay, now you could have had A as the second letter. Now you have A, and then you can put an O blank. A is still the second letter, but now you have blank O. You're still preserving the A to come before the O, and those are the only two you can get there. And then finally, you could have had A as the third letter. We have first letter, second letter, third letter, but there's only one here, AO. Right? Okay, so the first question is, in how many ways can I select A and O? And you see that is 1, 2, 3, 4, 5, 6. Right? So A and O can be any one of these 6. And then as far as these are concerned, you're left with only 2 letters, which are S and M. You can put S and M, or you can put M and S. Still doesn't alter the position of A and O. So this combination here gives you 2, and here you got another 2 because you can interchange those 2, and so on. And so altogether you got 6 pairs of two numbers, SM, MS, and so on. So that gives you 6 times 2, which is 12. So you could have argued it logically like this by writing it like this, rather than listing it all completely. But the important thing here is that if you notice, when I counted the number of ways here, I had 3 here, where A was the first letter, 2, where A was the second letter, and 3, 1, where A is the third letter, right? So in other words, the number of ways of doing this is actually 1 plus 2 plus 3. You could have done it like that. If A is the first letter, there are 3 possibilities. If A is the second letter, there are 2 possibilities. If A is the third letter, there's only 1 possibility. So altogether, you've got this, right? And then I look at this. The number of ways of selecting 2 spaces, these are 2 spaces from 4 spaces, is 3 plus 2 plus 1. I generalize this. The number of ways of selecting 2 spaces from n spaces, if I've got n rather than 4, I'm moving away from the given problem, right? Please, I've solved this problem. The answer is 12, right? Now I'm asking the question, if I had a word which has got n digits, n numbers, letters in it, how do you solve that problem, right? So I'm looking at the general problem. So I'm not specifying the number of letters to be 4, but I'm saying the number of letters is n. N can be anything. So if you look at this formula here, this is 1 plus 2 plus 3, this is 1 plus 2 plus 3, up to n minus 1, because it finishes off at 3, then there were 4 spaces. So it will finish off at n minus 1 if there are n spaces. Now spaces doesn't mean anything. You could have said objects. The number of ways of selecting 2 objects from n objects is, now there's a formula for this. The sum of the first n minus 1 natural numbers is n minus 1 times the next one divided by 2. And you've seen this, 1 plus 2 plus 3 up to 69 is 69 times the next one, 70 over 2. So that's what we got here. It's n minus 1 times the next one divided by 2. But if you want to write it down with a larger one in front, you could have written it as n into n minus 1 over 2. This is the crux. So I want you to remember this last sentence that we did, because that'll come up quite often. The number of ways of selecting 2 objects from n objects is n into n minus 1 over 2. Okay? And there's your example. If you want to select 2 objects from 100 objects, it'll be 100 times 99 over 2. And in our particular case here, we wanted to select 2 spaces from 4 spaces. So the answer would be, from 4 spaces, it will be 4 times the one before that divided by 2, and that gives you 6. And that's how you get these 6. Choosing the 2 spaces from 4 spaces. And then you say, but each thing here corresponds to 2 words. So you'll get 6 times 2 is 12. Okay, I took a long time to do that because that principle is very important. This number of ways of selecting 2 objects from n objects is that it comes up quite often. So I just wanted you to know how to do that problem. Okay. Let's get on to the next one. Now here, let y equal mx plus b be the image when this line now this equation is the equation of a straight line, because you can rewrite it as 3y, you can make y the subject, 3y equals minus x minus 80, and y is equal to minus x over 3 minus 80 over 3. So this is the equation of a straight line. This is of the form mx plus c, and this is your y-intercept, negative 80 over 3, and your gradient is negative 1/3. So this is the equation of a straight line. So it's quite correct to say that this is a straight line. Now the straight line is reflected in the x-axis. What do you mean by that? When you say it's reflected in the x-axis, it means that the x-axis acts as a mirror. Reflection, right? It acts as a mirror, and this line here is transported across this mirror, right? And you want to see what its shape looks like. So I have actually drawn it here. So there's my line, x plus 3y equals 80. And you will see the y-intercept is minus 80 over 3. Right? I've drawn the line in blue. That's the line that was given. Now this line is reflected across the x-axis. So every point on this line, the x-axis acts as a mirror, and you shoot it across to the other side. Right? So it must go to the same distance to the other side. That's what mirrors do. So if you take minus 80 over 3, this is a mirror, and it goes to plus 80 over 3. Right? So that happens to all the points, and you can see this is what happens. Right? This point here just remains as it is, right? Because it's on the axis itself. But this is the point that I'm interested in. If you take a general point, or let's take a point here in the blue, right? That point is reflected. If you take a general point, let's call it xy. So what happens to that point? It goes to, the x-coordinate remains the same, right? Because it's the same distance from the y-axis, this point here. X-coordinate remains the same, but the y-coordinate has changed sign. This was y, but now this new point, the y-coordinate is that one, which is minus that one. So these two have got equal lengths. But this thing here is y, because when you say the xy, it means x is that from there to there. That's your x, and y is from there to there. Always remember, when you got a coordinate thing, the x is the distance along the x-axis up to the origin. That's your x. And the y is from the x-axis to the point, right? So that is y. So when you reflect this thing, the y becomes minus 1. Now, this is very important, because that means that all the points in the reflected line, now we know it's a line, right? The y becomes minus y. The x remains as it is. That's very important, right? Because in this new line, the original y becomes minus y. So if you are looking at, this is your original equation, as we saw, x plus 3y equals 80, right? And when you reflect it, the new line will have, the y will now have to be replaced by minus y. Can you see? This is x plus 3. The y now becomes minus y, because the y of the blue line is the minus y of the red line. Right. Now, when you look at this, the question here, the question in this problem is, when you reflect it, go back. y equals mx plus b is the image when this line is reflected. So the equation of this line that we have drawn is given in this form. So this is the red line. This is a reflected line. You have to find what m is and what b is in that red line, because the problem is to find the sum of m and b, right? Always look at your question. So you have to find m and b in the reflected line and then add the gradient and the y-intercept. So let's do that. But the moment you got it like this, now you can see what this is going to be in terms of y. You can make y the subject, and you see that when you make y the subject here, you'll have y equals 1 over 3x plus 80 over 3. So this is your m, and this is your b, because this is the equation of the reflected line. So your m plus b will be 1/3, right? That's your m plus b, which is 80 over 3. So 1 over 3 plus 80 over 3 is 81 over 3, and the answer is 27. Okay, the reason why I took so long over this is to make you understand what do you mean by the equation of a straight line. You see, every point on the straight line satisfies this equation here. The xy satisfies this equation. Now, when you reflect it to this, you want to know what equation is satisfied by this point. And you will see that you already know that xy is here, satisfies this equation, but the y is now replaced by minus y, and that will be the new one. That's what I've done. Okay. That requires understanding, and you have to understand graphs and I hope that enhances your understanding of graphs. All right? Because very often people study graphs in a very mechanical way without knowing what the x and the y mean. Always go back to that. What do you mean by x and y? X is that distance from the origin, and y is the vertical distance. Always remember that that is what they mean. So don't just work with the algebra, but understand what it means in the geometry, in other words, in the picture of the graph. The next question says, 2 congruent rectangles are drawn. Now, congruence normally you use only for triangles, but the word congruence can be used for any shapes. That means 2 identical shapes. So you got 2 identical triangles are drawn here, identical rectangles. You can see these are identical. So that means if the length here is A and the breadth is B, this is also A and this is B. And they're identical rectangles. Now, the area of the rectangle is 12. So it means that, so I've given names to these sides, right? That they were not given. So immediately I put names to them. Because the area now I can calculate. Area is length times breadth. So that translated in the equation means A times B, which is AB. That is equal to 12. So you've got an equation. Its perimeter is 14. So the perimeter of this is 2A plus 2B. 2A plus 2B, and that is 14. And that gives you that A plus B is 7. Now, those 2 pieces of information, if you read it in words, you've got that the product of 2 numbers is 12, and the sum of those 2 numbers is 7. Now, you don't have to go around trying to calculate this thing. Mentally, you can see which 2 numbers, when added, give you 7, and when multiplied, give you 12. So the answer is quite obviously 3 and 4. So A and B are 3 and 4. So I can put 3 here and 4 there. So just looking at the given information, we can calculate A and B. Now let's have a look at this. They say the circumference of the circle is n pi. Now the circle comes into play. And it's given that the circumference is n pi. So what is the circumference of a circle? What's the formula for the circumference of a circle? So the formula for the circumference of a circle is either 2 pi r or if you like pi times diameter, where d is the diameter, right? That's the original definition of pi, the ratio of the circumference to the diameter of the circle. So pi times the diameter is the circumference, and the diameter is twice the radius. Okay. So in other words, you know, you need to calculate this. Now, where is the diameter of the circle here? Well, if you look carefully, you'll see we can't draw the diameter. But I don't know if it's the diameter. If I join this point to that point, it kind of looks as if it's the diameter. And the fact is, it is. The reason being that this angle is 90 degrees. It's a rectangle, you see. So this angle is 90 degrees. So if you look at this picture here, you can see that this thing here, it subtends 90 degrees. Those people who have done circles will see that this makes 90 degrees. But always remember, even the grade 10 people, remember that in any circle, it's a very useful property that if you take any circle, sorry, that doesn't look like a circle. We'll draw a decent circle here. Whenever you draw any circle, right, and if you draw the diameter, it's a useful fact. Draw any diameter. The diameter is the longest chord. You draw any line through the center. That's the diameter. Any line through the center of the circle. And the interesting thing is, very interesting thing is that when you join, you take a random point in the circumference, like this one, and I join one vertex, one end of the diameter to that point, and take that point and join it to the other end. The remarkable thing is that this angle is always 90 degrees. Doesn't matter where you choose this point. You go from here to there, that's 90 degrees. There to there, 90 degrees. So you got all these are right angles. Very useful. So therefore, you got this in this 90 degrees here. So this part here is your diameter. But now you can calculate the diameter because you got A and B. And so the diameter, if you're calling it that D, you can calculate it because that's your diameter. And Pythagoras kicks in because you got 90 degrees. So D squared is equal to A squared plus B squared. And we already calculated A and B. A was 3 and B was 4. And 9 plus 16 is 25. So D squared is 25. So D is 5. So the diameter is 5. So this is 5 pi. The circumference is equal to 5 pi. But they tell you that the circumference is n pi. So therefore, n must be equal to 5. Sorry, this everything is all tilting here. Okay, part of it is, the reason is I'm left-handed. All right, let's have a look at this. Look, you can go over it and you will see that basically we are using the information. What is the formula for the circumference of a circle? It's pi times the diameter, or if you like, you can use pi times 2r, either way. And then when you solve for r, you will still work out the circumference like this. And then but you know that the circumference is n pi, so you can calculate the circumference, and you know it's n pi, so n is equal to 5. Okay. All right, so the next question is, for how many positive integers k does the equation kx minus 12 equals 3k have an integer solution? Now it looks as if it's very difficult to say, oh, you got two unknowns, k and x, and as a novice, you will try to find x, solve for x, solve for k, and you'll be just running around in circles. You wouldn't know what to do with this. Right? And you want to know how many values does it have an integer solution. So we have to see what you're talking about. Positive integers. So the k values are like this. They are positive integers. These are the possible values for k. Right? So the question is, if I substitute a positive integer for k, I need the solution for x to be an integer. If I make, for example, if I make k equal to 7, then what do you have? 7x minus 12 equals 3 times k. Remember, k is 7, that's 21, and 7x is equal to 33. Bring all the numbers to one side, but x is not an integer, because 7 times x gives 33, x is not an integer, it's a fraction. So k equals 7 doesn't work, not allowed. So the question is now, which k's are allowed? That is really the question. And actually the problem is very easy, because I'm going to rewrite this as kx minus 3k. I'll bring all the k's to one side and bring the 12 to the other side. Bring 12 to this side, bring the k to this side. And then I've got k into x minus 3 is equal to 12. And now x is an integer. So this is a whole number. And this is a whole number. It's a positive whole number. So when you this is a positive whole number. So you want to know these two whole numbers are multiplied to give you 12. What is that? That's only factorization. And when you factorize a number, right, you're writing it as a product of two whole numbers. So k is now a factor. That is the important thing. K is a factor of 12. The reason why we can say that is that because these are integers. They're whole numbers. When you multiply two integers together, you get 12. So each one is a factor. Right? So what are the factors of 12? We want them to be positive. So they are numbers from here, and you can write them down. 1, 2, 3, 4, 6, 12. Those are the factors of 12. But the question is, how many positive integers are there? You can count how many there are. So there are only 6. Because there are only 6 factors of 12. You see, you boil this thing down to finding the factors. Note that k is a factor of 12. It's a positive factor of 12. And how many positive integers means that how many positive factors do you have of 12? And you write them down, and the answer is 6. Okay, so if you take the next one. Now this is another problem involving positive integers. You see, there are lots of questions involving positive integers, and positive integers you study when you are in primary school. In high school, you just say x, and x is any real number. It can be, a fraction or a square root of 2 or whatever. But x in high school are all real numbers. But here, these questions are always on positive integers, and you study positive integers in primary school. So if a, b, and c are positive integers such that you got this funny looking thing here. What is the value of a plus b plus c? So I'm going to write 30 over 13. And I wanted to write it as an integer plus something. Now you can write this in integer. This is 13 goes into this 2 times 26, remainder 4. So you can write this as 2 plus 4 over 13. So the possible value for a is 2. Right. Now you want to write this 4 over 13. 4 over 13. This is the part here. You want to write it like this. I'm just going to say you're going to write it as 1 over something. Let's not worry about this stuff here. But you want to write this remaining part, this is 2, the remaining part as 1 over something. And yes, you can do that. 2 plus, this is 4 over 13 is 1 over 13 over 4. You just have to invert it. All right, so I've got it as 1 over 13 over 4. And now you want to write this 13 over 4, right? That's at the bottom, as an integer plus something. So once again, you can write 13 over 4, right? You can write it as a mixed fraction, and you're left with 2 plus over 1 over 4 goes into 13 3 times, remainder 1. So you can write it as 3 1/4 or 3 plus 1 over 4. And there you have it. You've got exactly the same form. See, A is 2, B is 3, and C, 1 over C, 1 over 4. So you can C is equal to 4. And the problem was, what is A plus B plus C? We got A, B, and C. So you just simply add 2, 3, and 4. And the answer is 9. Okay. So again, now this is, you have to think about what the question is and try to figure out a method of getting to the solution. So here, a little bit of thought will tell you, I got this and I got a whole number plus something, and you know how to do that. This is a mixed fraction. You can just write this, do a long divide, and you get 2. That's your whole number plus the remainder. And then from there, you just proceed again logically, ask questions along the way, because you need to get to the answer. And you will see the answer just automatically makes its appearance. All right, we now go on to problem 15. Problem 15 says a square tile is divided up into 4 smaller squares. So there's the tile here. It's divided into 4 smaller squares, as shown. Each small square must be painted using one of the colors, yellow, red, or blue. So you got 3 colors, yellow, red, blue. Each small square must be painted. Right, so you can put yellow here, put a B here, and R here, whatever it is, right? So you can put any of these colors in those 4 tiles. All right. Can you just excuse me, please, just for a minute? No. So we can say paint these tiles in any one of 4 colors. Now, if you continue the question, it says, how many different tiles can be painted if exactly 2 colors are used per tile? So in other words, of these colors, I need to use only 2 colors. I could use yellow and red, for instance, or yellow and blue, or yellow and blue, sorry. Or you can have red and blue. I think that's only 3 ways you can have 2 colors from 3. All right. So you can have any one of these. All right. So let's take, they want to know in how many different tiles can be painted. But they also say that 2 tiles are considered to be the same if they can be rotated to look the same. Right. So when you paint it, and if you rotate it, right? If you have 2 different tiles and you rotate them and they look the same, and you come back to the same tile, then you don't count them as different. You count them as the same. Right? Okay, let's just unpack that. So I've actually drawn a case here. I've chosen, in this case, I've chosen red and yellow, and I've taken all the cases. And let's see, what did I do? I want to be systematic about this. I need to put 2 colors. So suppose I say one of them is yellow. I'll do it like that. 1 yellow, and then I count how many there are. 2 yellows, count how many there are, and 3 yellows, count how many there are. Right. You can't have 4 yellows because you need to have 2 colors. So there are only 3 cases. You either have 1 yellow, or 2 yellows, or 3 yellows. Right. And if you got 1 yellow, that yellow has to be in a corner. Now you might think that this is different from this. If you take a different and you might put a yellow, you might decide to put a yellow here and put red there. You might think that this is different. But if you read the question carefully, it says, when you rotate this thing, I can rotate this. You can see if I rotate this, right, I can always get to this. I just turn it twice, right? Turn it to 180 degrees if you like, and you'll get to this. So this is no different from that. They are the same. So if I got a yellow in a corner, I only count it once. So there's 1 there, right? Because there's no other way. If the yellow is in the corner, you can always bring it to this. But in this case here, now I finished the one yellow. You've got 2 yellows. I could have 2 yellows like this. And again, if you have any 2 yellows on the side there, you can rotate it to be the same. So there's 1 here, right? And this is the different one. You'll never be able to get rotating this to get to that. These are the only two possibilities if you got two yellows. Yellow, yellow along the diagonals or along the row. Okay, and this too, if you rotate it in any way, you might have had red, red, and then yellow, yellow here, but you can see clearly that you can turn it around to get exactly the same thing. So you only count that once. And here you got three yellows. And again, there will be, just like in that case there, in that case, you're going to only got exactly one red, and then there's only one case. So the answer is 4. If you take red and yellow, there are 4 for those two colors. But bear in mind that you could have had blue and yellow. So the same, again, the same story. And you got red and blue, will give another 4. And those are the only 3 combinations you can have for 2 colors from red, yellow, and blue. So the answer is altogether you got 4 plus 4 plus 4, which is 12. 4 for that case, 4 for that case, 4 for that case. And altogether you got 12 different possibilities. Okay. The next okay, I'm not going to spend too long on this because this can take a long time. Let's just skip this thing here. It uses a theorem which at some time learners used to do, but these days I don't think the theorem occurs. So I'll just avoid that. If I got time, I'll come back to it later on. So let's go to problem number 17. A sporting club has 100 members. Of these 100 members, 44 play soccer and so on. There's a lot of information given here. Some people play soccer, then 45 play cricket, some play rugby, some play soccer and cricket, and so on. A lot of information here. And 5 play neither soccer, cricket, nor rugby. And how many members play rugby only? It looks extremely complicated. But problems like this can be very nicely solved if you use what you call Venn diagrams. See, I'm going to show you what you mean by Venn diagram. If you put all the people who play soccer inside that circle, this is the soccer people. And then if I put all the people who play cricket inside another circle, these are the people who play cricket, and then all the people who play rugby into another circle. Now, these circles here, the way I've drawn them, it means that the soccer people, none of them play rugby because they are separated. Right? The rugby people, nothing in common with soccer. But a little bit of thought will say that I can have a situation like that. Right? When you have that, now you got the soccer people, the soccer rights. Let's call this soccer S and rugby. Now all the soccer players are inside here, all the rugby players are inside here. So these people here, they are in the S circle and they're also in the R circle. So these people play soccer and rugby. And those here, they play soccer, but they're outside rugby. So they play soccer, but they don't play rugby. And here, they play rugby, but they don't play soccer. Right? So when you got 2 sports like that and you put them together, you can see, you can separate them quite nicely to identify who plays soccer, who plays rugby only, who plays soccer only, who plays both, right? But here you've got a cricket as well. To make matters a little bit more complicated, you've got people play cricket as well. So you have a third force coming in. So you have that situation. And now you've got various kinds of areas. And now these are the people who play soccer, rugby, or cricket. But there are some people who don't play anything at all. You see, there are 5 people who play neither soccer, cricket, nor rugby. They don't play anything at all. So it means there are some people who are outside this lot. They're not in any of these, but they are inside the school or inside the club, right? So in that case, you have a large club here, right? And these club has got people who are members. There are 100 people there, and that's your club there now, like that. Right? And all these are members of the same club. This is the large one, and the people outside here are people who don't belong to any of the circles. So they are the people who belong to this outside group. Now we know the numbers for each, for different things here. So we have to unpack what those numbers mean, all these things, right? And for instance, now, you got 44 play soccer. So the total number inside the circle is 44, which means that that piece, that piece, that piece, and that piece, those 4 numbers together add up to 44. All right. Now you also know that, let's just go further down. 7 people play soccer and rugby only. So this is a cricket. It's a new one. 7 people play soccer and rugby only. In other words, this part here are people who play soccer and rugby only. Now here, these are the people who play all 3. We don't know, that's not given. We're going to call that X, right? I'm going to start here, because from here we'll be able to figure out what's going on. Now the soccer and the rugby people, soccer and rugby, these 2 together gives you 7 people. Okay, I'm going to put a tick there to say I'm going to use that. So that part there will have to be 7 minus X, because these 2 together gives you 7. Now, what are these people? These people here are people who play soccer and rugby, but not cricket. Right? These people here. Okay, likewise, there are 9 people who play rugby and cricket only. So you got rugby and cricket. There are 9 people. In that lot there, rugby and cricket. There's X here who play rugby, cricket, and soccer. So these people here on this side will be 9 minus X. So we can take care of that. And also 8 people play soccer and cricket only. So likewise, you have this 8 minus X. Right? Now you got 3 of them here in terms of X. And you know that there are 44 people play soccer altogether. Right? What does this mean? That when you add those 4 numbers, that one, that one, that one, and that, you'll get 44. Now you can try to figure out how it's going to work out. 7 plus 8 is 15. 15 minus X plus that is 44. And I see you're going to have X plus 29. This part here will be X plus 29. If you add up all these numbers, you will see you get 44. Right. Now, I've done this whole thing in full. So I'm going to go to this picture here so you can understand what's going on. You can see here, I've got, 29 minus x. Oh, I'm sorry. I misinterpreted this. 8 play soccer and cricket only. 8 play soccer and cricket only. They don't play rugby. So this part here is 8. So it's easier than what I thought it was. Because they play, these people here, soccer, cricket, and these people, all these people play soccer, cricket, and some of them play rugby. Right? A small piece. But the people who play soccer and cricket only are here. So the 7, 8, and 9, they fit in neatly inside here. Right? And then you can calculate this whole thing here. There are 44 people here. Right? So you can, if you add up these 4 numbers, you will see minus x plus x cancels. And you have 7 plus 8 is 15 plus 9, 29 is 44. You can calculate each of these by adding these and subtracting it from whatever the number was. I think in this case it was 50 to play rugby altogether, right? If you add these, you get 50 and so on. So you can fill in all these things. And remember, there are 5 people who do not play any of these. So there are 5 people outside. So you got this 100 people in this club, right? The 100 people who are members of this club, you got them separated into various groups, right? And all these, they add up to the 100 because there are 5 people who didn't play any one of those, and the others play one of those. And if you add up all these quantities, you're going to get 100. So that's the equation that we get, which I'm not going to worry about. But in the end, you see that the value of x is 10. You have an equation involving x. You add up all these together with your 5, and you will land, and that is equal to 100, because that gives you the whole population of the sporting club. So you have an equation. There's your equation here. It's equal to 100. Solve for x, and you get x equals 10. But the question is, how many people play rugby only? In other words, they play rugby, but not soccer and not cricket. If you go to the rugby area, you will see that the people here play rugby only. They do not play soccer and they do not play cricket. So you want to know how many people there are here. When we did the calculations, we saw there were 34 minus x in that region, and x is 10. So that is why it's supposed to be 34 minus 10 are the people who play rugby only. All right, so these are Venn diagrams. You will do these when you reach grade 11, grade 12, somewhere along the line. It's in your syllabus. So I've given you a sneak preview of what these things mean. And they're very interesting problems where you can solve rather complicated problems like this one by drawing a diagram and interpreting what these little areas are and making conclusions. Okay. All right, so we've come to the end of problem 17. And I think what we are going to do is we've still got 8 more problems to go. I don't want to take your time because it's now 6 o'clock, and some people might want to go away. Now let me just do one more, because we did start a little late. Let's do number 18, and then we'll leave the remaining 7 for next week. Now the question here is, how many odd positive integers, the sum of whose digits is 4, and none of whose digits is 0, are not prime? You know, in many of these problems, you have to interpret these questions to understand what are they saying, right? But you have to go piecemeal. You got their positive integers. So firstly, they're coming from these numbers here, 1, 2, 3, 4, and so on, right? So we are looking for these numbers, but they must be odd. So we're looking at 1, 3, 5, 7, 9, and so on. Right. So in this lot here, you're looking for those numbers whose sum of the digits is 4, right? So there could be more than one digit. In fact, there should be more than one digit. So let's see if they are two-digit numbers. There can't be one-digit numbers because one-digit numbers, these are the one-digit numbers. The sum is definitely not 4. If you take two-digit numbers, so you got they are odd. So if you look at the tens and the units, the you could have had 1 there, or you could have had 3 there. You can't have 5 or 7 because when you add them, you're going to get 4. So if you look at this, there's only one way in which you can fill this. If you got a 3 as your units digit, there is only one number whose sum is 4. But in this case here, you could have had 1 and 3. Okay, that's fine. But you could have had a 3-digit number with a 1 as an ending here. And these two now will add up to 3. And that's quite possible. You could have 1 plus 2, or you could have 2 plus 1. So you could have had a 3-digit number. But those are the only possibilities. This does not give you 3-digit numbers. But the 1 does give you 3-digit numbers where those remaining 2 must add up to 3. And in fact, you can have even a 4-digit number. But then you will have 1, 1, 1, 1. In this case here, you could have had 1, 2, 1, or you could have had 2, 1, 1, 1, 2. Oh no, you can't. You can't have that, obviously, because right, you can't have 1, 1, 2 because it's an odd number. So we've taken care of all this. So you got the only 5 numbers which fit the bill, right? Then there's only one number which ends in 3, and there are 4 numbers whose sum is 4. They're odd, and the sum is But you want the numbers to be not prime also. In other words, they must not be prime numbers. They must be composite numbers. Well, 31 is a prime number, so you can rule it out. That you can see has got no factors, right? This is fine because 121 is 11 times 11. That's not a prime number. So we allowed that. And here, this is not a prime number also because it's 11 times 101. 11 goes into this. But you're not allowed this because this is prime. 13 is prime. The only thing that remains is 211. And you can check to see that 211 is a prime number. You can try the numbers, try to see which numbers can be prime factors. You have to try the prime numbers, 3 and, well, obviously 5 doesn't go into this. Try 3, 7, and 11, and 13 maybe. But that's all you need to go up to because after that, you're going too far. You only need to go up to this because 14 times 14 is 196. So you go up to 13, and the next one should be 17. But 17 will give you the other factor will be smaller, and we've already taken care of that. Anyway, whatever this is, you can check to see that this is a prime number. So it's out. So there are only 2 numbers. So the answer is how many odd positive integers? And the answer is 2. You have to list them and see which ones satisfy the property and count them. There are only two which satisfy the property. The others are prime numbers, right? And it was specifically asked that it's not prime. Okay, I'm going to stop there. We went up to problem number 18, and next week we'll do problem 19 to 25. It's the third week. And then the last week, third week, and we will do, we are still doing 2019, are we? We might just do 3 years, or might just select some problems from the last 2 years, because we would not be able to finish 100 problems. It takes a long time to go through all these, and I'm sure many of you are, after 2 hours, your minds are all dead. And we rather not do too many. Maybe we'll just do 3 years of problems. Okay, I've been speaking all the time, and let me just come out of this sharing. And I'm happy to see that there are still 90 participants. A number of them have left, but that's okay. Now, okay, so there were people who were chatting in this chat column, and my friend Patrick Rasovete, I don't know whether he's still here. I must thank him for assisting. He's from the South African Maths Foundation, and I forgot to invite him in the rush of having to listen to Perpetua from the Minerva University. Anyway, so we didn't have any interruptions. All right, let me just see what kind of questions are asked here. Somebody, Milana, says, can you share the questions you are doing? Was I not sharing it? Okay, let's just see. What is problem 5's answer? I'll come to that now. Okay, somebody give the answer to that. The thing was 120. And what was problem 4 and 6 answer? Okay, everything is recorded. So all you have to do is, when you get to this later, when the recording comes to you in a few days' time, maybe 3 or 4 days' time, you can go and check it out and you can get the answers to your question, right? Okay, so all right, now you can unmute and you can ask me your questions if you have any questions, and I'm going to write them down and I will answer the questions for you. Miranda? Are there any questions? Rishta, you can unmute.
Yes.
I'm surprised. Okay, somebody has written down. Sir, for question 24, how did you know angle EAB was theta? Oh, all right. Let's go and answer that. That's a good question. Now, in question 24, that was the previous 2018. Right. So what we said here was
Never.
this angle here. We call this angle here theta. Let me just get my act in order here. We call this angle here theta. Right. Now, the person wanted to know, why did I call this theta? The answer is as follows. See, let's have a look at that angle. Question mark. When you add these two angles, what do you get? 90. So what is this angle? This angle, oh, I'm sorry. This angle here is 90 minus this one. The question mark is 90 minus this one. But you'll notice that these two angles also add up to 90. So this angle here is 90 minus theta. See? So this angle has to be theta. Or if you want, you can call, let's put it this way. Let's call this whatever, Z. And call this Y. Right, what is Z plus theta? That's 90. Because this is a straight line, this angle is 90. Now, in this case here, what is Z plus Y? Z plus Y is also 90. See? Because they are angles in a triangle. Because Z plus theta is equal to Z plus Y, cancel the Z's, and Y is equal to theta. See? Theta is equal to Y. That's why we can replace this by theta. Okay, I hope that answers your question. What's the next question? It seems to me, let me just unmute you. It seems to me that I muted all of you, so. All right, now you can speak to me, I think. Okay. Sorry, this I'm not too familiar with. Stop the share. Right. Are there any questions now? Can I ask you? I have unmuted you so you can talk to me. I can hear Miranda, but she's got some conversation with somebody else. So there are no questions? Nobody has got any questions?
So on your problem 6, how did you get your answer?
Problem 6, is it?
Yes,
Okay.
sir.
Okay, this one here. Yeah, well, this is a, I came to this equation x plus x over 4, because x has to be added to 1/4 of itself. This is your addition, and the result is 30. Now you multiply right throughout by 4 times x. If you multiply this by 4, you get x. The 4's cancel. 4 times 30 is 120. So what you do to one side of the equation, you can do to the other side. So multiplying everything by 4, and a 4x plus x is 5x, is 120, which means that 5 multiplied by x, 5x is 5 times x. 5 multiplied by x is 120. So x will have to be 120 divided by 5. and the answer is 24. Okay, is that okay now?
Yes, sir, I understand now.
All right. Okay, any other questions? No questions. All right. It means that you seem to have followed everything quite nicely. If there are no questions. So next week, we will do problems from 18 or 19 to 25. All right. I'll see you next week at the same time, and enjoy the rest of the week. Let me just see if there's something in the chat column. Oh, there are some questions in the chat column. Okay, I answered the first question. So you ask, when are you going to write round 2? I think round 2 is going to be written in May. I think it's the second week in May, around the 12th of May or thereabouts. Okay, I can't remember offhand where it is, when you're going to write that. I will tell you in a moment. Okay, for some reason I can't seem to get it, but it's I think it's on the 12th of May or thereabouts. Okay. Yeah, okay, I got it now.
Points.
Okay, I'm not sure. It's I don't seem to know, but I cannot answer that question. But you're gonna have to go and Google it, or otherwise next week I will let you know the answer to that question. Right. The next one now, Degal's. She says, "What can one do to improve their logic skills in mathematics?" Can't answer that in one sentence, Degal's. There's no method of improving your logic skills. But what's a useful thing is do everything step by step. You do it, start from where you are and build up from there. Don't run into the end result. And then you take what is given and you slowly understand what the question is, as I do, and then ask, understand what is given and slowly work yourself up towards the answer. All right. Then
my phone. Out Wi-Fi now.
Okay, and then Sonlia asked, is the answer to question 520 or 60? I've forgotten what it was. I think it was 120.
You are in phone.
There's somebody speaking. Can you please just mute whoever you are? There's somebody who is speaking into the microphone and I can hear them.
These people are trying to sell me out.
Okay, there doesn't seem to be any other question in the chat column. I've read all of them. Okay, thank you very much and goodbye. Have a good night.
Will it be visible to everyone? Yes.
We hope you enjoyed this Olympiad training session with Professor Pillay. Remember, practice makes perfect.